All right, guys, section 3 of chapter 10. Now we're going to do some operations with radical expressions. So previously we simplified radical expressions. Now we're going to add and subtract radical expressions as well as multiply radical expressions. And that's just basically what operations with radical expressions entails. So to add or subtract radical expressions, the radicands must be alike in the same way that monomial terms must be alike to add or subtract. So if I had the monomials 4a plus 2a, I could just add the coefficients and get 6a. Well, if I have 9b minus 2b, those are like terms because they have the same variable and the exponent on the variable is the same. So I just subtract the coefficients and get 7b. Well, with square roots, it's the same thing. If you have the same square root, you just add the coefficient in front of the square root. So if I had 4 square root 5 plus 2 square root 5, I would have 6 square root 5s altogether. Or when you're subtracting, you just subtract coefficients. 9 square root 3 minus 2 square root 3, just subtract the 9 and the 2, and you get 7 square root of 3, okay? But if I had 9 square root 3 minus 2 square root 5, that's already fully simplified because the radicands are not the same, okay? All right, so notice that when adding and subtracting radical expression, the radicand does not change. And that's the same when adding or subtracting monomials. Like the a and the b didn't change. Here the 5 and the 3 didn't change. Okay, you're just adding and subtracting coefficients because the coefficient is basically telling you how many of each of them you have. If I have 4 square root of 5 plus 2 square root of 5s, then I have 6 of them altogether. Just like if I had 4 bananas and 2 bananas, that would give me 6 bananas. Wouldn't change the banana, would it? All right, so let's simplify this one. 5 square root 2 plus 7 square root 2 minus 6 square root 2. You would just basically add the 5 and 7 and then subtract from that the 6, and you get 6 square root 2. What if I had 10 square root 7 plus 5 square root 11 plus 4 square root 7 minus 6 square root 11? Well, you would add the square root of 7s together and subtract the square root of 11s. So be careful here. You have 5 square root of 11 minus 6 square root of 11, which would give you negative 1 or minus 1 square root of 11. And you could put the 1 in there if you want to or not. And then if I have 10 square root 7 plus 4 square root 7, that gives you 14 square root 7. Okay, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So for 1a, you would just do the 3 minus 5 plus 4 square root 2, which gives you 2 square root 2. For b, you would do 6 plus 2 minus 9 square root of 11, which gives you 6 plus 2 is 8 minus 9 is negative 1. So you could have negative square root 11. So 1c, I like to look for my like terms. So 15 square root 3 minus 11 square root 3, 15 minus 11 would give you 4 square root 3. And then negative 14 plus 6 would give you negative 8 square root of 5. 1d, put the square root of 3's together first. So 4 minus 6 would give you negative 2 square root 3. And then 3 square root 7 and 3 square root 7 would give you plus 6 square root 7. Okay? All right, pretty cool stuff there. Not all radical expressions have like radicands. Simplifying the expressions may make it possible to have like radicands so they can be added or subtracted. So let's look at this one. Simplify 2 square root 18 plus 2 square root 32 plus square root 72. Well, 18, the square root of 18 can be thought of as 9 times 2. 32 can be thought of as 16 times 2, and 72 can be thought of as 36 times 2. So when you simplify those, the square root of 18 is really 3 square root of 2, the square root of 32 is really 4 square roots of 2, and 72 is really 6 square roots of 2. Now, since the square root of 18 was already multiplied by 2, that would come out to be 6 square roots of 2. Since the square root of 32 is already multiplied by 2, it would come out to be 8 square roots of 2. Plus 6 square roots of 2. Now that I've simply or fully simplified each radicand, or each radical, they all end up being square roots of 2, so I can add those all together and get 20 square root of 2. All right? Okay, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So 2a, 4 square root 54 plus 2 square root 24. So 54 is 9 times 6, and 24 is 4 times 6. Okay, so this is going to end up being 4 times 3 square root 6, and this one's going to be end up being 2 times 2 square roots of 6. So you'd have 12 square root 6 plus 4 square root 6, and that comes out to be 16 square roots of 6. Okay, cool. 2b, 4 square root 12 minus 6 square root 48. 12 is really 4 times 3, and 48 is really 16 times 3. So this becomes 4 times 2 square root 3 minus 6 times 4 square root 3. And now you can see that they have like radicals. So you have 8 square root 3 minus 24 square root 3. So negative 16 square root 3. Okay. 2c, 45 is really 9 times 5 plus square root 20 can be thought of as 4 times 5. And 245 can be thought of as 49 times 5. Now, how did I know that was 49? Well, I saw that these first two are going to simplify to a square root of 5. So I thought, well, let me divide this by 5 and see if the other number is a perfect square. Well, 245 divided by 5 is 49. Perfect square. Boom. Okay, so you get 3 times 3 square root 5 plus 2 square root 5 minus 7 square root 5. So you'd have 9 square root 5 plus 2 square root 5 minus 7 square root 5. 9 and 2 gives me 11, minus 7 would give you 4 square root of 5. Okay? All right, last one here. Square root 24 is 6 times 4. Yeah. But let me write it as 4 times 6. This is 9 times 6. And again, I'm seeing that the first two are factors of 6. So 96, if I divide that by 6, I get 16 times 6. Okay? Which tells me that 16 is a perfect square. So I got 2 square root 6 minus 3 square root 6 plus 4 square root 6. So that gives me 3 square root of 6. 2 minus 3 is negative 1 plus 4 gives you 3. Okay? All right, guys, that's it for this video. Stay tuned for the next.